right, moving on with linear inequalities, we are going to look at a challenge problem and a real-world connection problem next. I encourage you to pause this video and try them on your own, and then check back in and follow along and see how you did. So for this first challenge problem on the left, our task is to write a linear inequality that includes some points, but then excludes some other points. Okay, so I think what I need to do is see a visual of this. So I'm going to graph those points up, and then we just need to see if we can fit a line that kind of divides the plane into two halves that separates those points. So let's get going with the graph first. And I will just have a regular scale of ones. So, and I'll try to color coordinate. Greens are what we're including. So we want to include that green. We want to include over 5, 1, 2, 3, and up 5. And we want to include -5 and up 5. 1, 2, 3, 4, 5. So those are the points we want to include. And then red will be excluding. So 0, -3. We want to exclude that one. 5, -5. And 1, -2. Okay, it looks like we have a few possibilities. I think the easiest one, I'm going to give you the easy answer, and then I'll look at maybe a more authentic answer. The easy answer is really just to draw a line there and shade everything above that line. Okay. And so that answer would be x is greater than or equal to -1. That would definitely work. But let's try to be a little more creative with this, and let's see if we can get let me erase that, maybe more interesting line that goes through. So here's what I'm going to do. I'm going to have the line go right through the origin, and I'm going to give it a slope of -1/2. Right there. And then we want to shade everything above that and including that, right? So my line here is y equals -1/2 x plus 0. So that would be the equation of the line. And then my inequality would be y is greater than or equal to -1/2 x plus 0. Okay, so that would be another solution to that problem. And there are many solutions there are infinite number of possible answers to this one. Okay, next one. My son saved $450 last summer from his lawn mowing job, and he is really into video games, and he's honestly kind of too into Pokemon right now. It's a little excessive. But a typical video game costs him $55, and he can get a 30-pack of Pokemon cards for $12. Write a linear inequality that represents the scenario and demonstrate some possible combinations of games and card packs he can purchase. Okay, so it looks like we're going to have something is going to be less than or equal to $450. That's the first thing that I notice right there. He has to spend $450 or less. But I want to define some variables first. Let x equal number of video games and y equal number of card packs, right? Okay, and so we're going to have some stuff that's going to be less than or equal to 450. So we just need to write out the scenario into math. So 55x plus 12y has to be less than or equal to 450. That's my solution right there. But I want to graph it. I'm going to actually graph this guy on Desmos, and we'll take a look at that over on Desmos. 55x plus 12y is less than or equal to 450. So let's type that in. Whoops. Plus 12y is less than or equal to 450. Okay, and let's try to get a better scale here. Okay, so let me get a screenshot, and we'll bring it back over to my note app so that I can annotate it a little bit. Okay, so let's paste that in down here. Okay, so here are the possibilities of what we could get. And to remind ourselves, X was video games. So this is my video game axis. And Y was the Pokemon packs, card packs, okay? And I hope you can also see that everything that's negative is going to be excluded, okay? We can't get negative video games or negative Pokemon. So we're really just looking at this zone in here, okay? And then everywhere inside that zone. So that's a kind of our solution area. He doesn't have to spend his whole $450. He could buy nothing and spend $0. But any point in there is valid. And as just one example, this is a valid point right here. He could buy 4 video games and 10 Pokemon packs, and he would be within his $450 budget. All right, and that's a good place to stop right there.